On June 30th, 1908, in a remote, sparsely populated region of Siberia near the Podkamennaya Tunguska River, the sky ripped open. A colossal explosion, estimated to be 1,000 times more powerful than the atomic bomb dropped on Hiroshima, flattened over 2,000 square kilometers of forest. That's an area roughly the size of Tokyo, for decades. This event, known as the Tunguska event, has been one of history's most baffling mysteries. What could have caused such immense devastation? For a long time, the leading theory was a meteor or a comet exploding in the atmosphere. It makes sense, right? An extraterrestrial object enters our airspace, heats up, and boom. Eyewitnesses reported seeing a brilliant fireball streak across the sky, followed by a deafening blast and a shockwave that knocked people off their feet hundreds of kilometers away. The sound was heard even further. Seismic stations across Eurasia registered the tremor. For several nights after the event, the sky over Asia and Europe glowed strangely, so bright that people in London could reportedly read a newspaper outside at midnight. But here's where it gets weird. When the first scientific expedition, led by Russian mineralogist Leonid Kulik, finally reached the remote site in 1927, nearly 2 decades later, they found something truly unexpected. Or rather, they didn't find something. They expected to find a massive impact crater, the telltale sign of a meteorite strike. But there was no crater. None. Instead, they found a vast, circular pattern of scorched and flattened trees, all pointing radially away from a central point. Now, the trees at the very center, the epicenter, were still standing, but they were stripped of their branches and bark, looking like a forest of telephone poles. It was as if a gigantic downward blast of force had pushed everything out from the middle. The lack of a crater and the absence of any significant meteorite fragments, despite extensive searches, threw a wrench into the simple asteroid impact theory. This opened the door to a whole range of other explanations, some more scientific than others. People have proposed everything from a tiny black hole passing through the Earth to an alien spacecraft crash. While these ideas are exciting, they lack concrete evidence. So scientists continued to search for a more plausible, natural explanation that fits all the strange facts. This is where we step away from the common narrative and dive into a less-known but fascinating hypothesis, the electrical storm theory. What if the Tunguska event wasn't caused by something from space, but by something generated right here, within our own planet's atmosphere? This theory suggests that the devastation was the result of a colossal discharge of atmospheric electrical energy, essentially a lightning strike of unimaginable scale. This isn't your average thunderstorm. We're talking about a phenomenon so powerful it could mimic the effects of a mid-air nuclear explosion. The idea was first floated in the early 20th century. It gained more traction with the work of scientists looking for alternatives to the impact theory. They pointed to the unique characteristics of the event. The bright, glowing sky is seen for days afterward, the reports of strange atmospheric effects, and the magnetic storm recorded by the Irkutsk Observatory around the time of the explosion. These could be signatures of a massive electromagnetic disturbance. So how would this even work? One version of the theory, proposed by physicists like V.A. Kozantsev, suggests a process involving electro-explosive phenomena. Imagine a huge buildup of static electricity in the atmosphere, far beyond anything we normally experience. This could be caused by specific solar activity or unique atmospheric conditions. When this immense charge finds a path to the ground, it doesn't just create a lightning bolt. It creates an explosive, downward column of plasma. This superheated plasma column would hit the ground and expand outwards with incredible force, pushing the trees down in that radial pattern just as Kulik observed. It would also explain why the trees at the epicenter were left standing but stripped bare. They were right in the path of the downward electrical current, which would have flash-boiled the sap inside them and blasted off their bark and branches. Another variation of this electrical theory involves something called telluric currents. These are natural electric currents that flow through the Earth's crust and mantle. The theory, sometimes called the Verneshot hypothesis, proposes that a massive bubble of superheated gas, charged with telluric energy, erupted from the Earth's interior. This geophysical explosion would have shot upwards into the atmosphere with tremendous force, creating the fireball and shockwave witnessed by so many. It would explain the lack of a crater, as the explosion originated from below the surface and vented through weaker points in the crust, leaving behind a scarred but not cratered landscape. This also ties in with the region's geology, as it's known for volcanic activity and deep geological faults. Think about the eyewitness accounts again in this new light. Many reported the fireball moving across the sky, changing direction, and seeming to pause before the final explosion. While this is hard to explain with a simple, ballistic meteor, it could be consistent with a complex plasma phenomenon, interacting with the Earth's magnetic field. The descriptions of a pillar of fire or a split in the sky sound less like a rock falling and more like a large-scale electrical discharge. Furthermore, the electrical theory could explain the strange burn patterns on the trees. The damage wasn't uniform, like you might expect from a simple heat blast. Some trees were scorched, while others nearby were untouched. This could be due to the chaotic and branching nature of an electrical discharge, which wouldn't heat the area evenly. The intense electromagnetic pulse generated by such an event would also perfectly explain the magnetic disturbances recorded at the time. Of course, the electrical storm theory has its own set of challenges. First and foremost, we've never observed an atmospheric electrical event of this magnitude in modern times. There's no known mechanism that we can definitively say could generate and release this much energy. While the theories are scientifically plausible, they remain speculative. It's difficult to prove because the evidence at the site has degraded over the last century. Most of the original fallen trees have rotted away, and the landscape has regrown. However, recent research continues to keep this theory alive. Scientists studying high-energy atmospheric phenomena, like sprites and elves, which are large-scale electrical discharges that occur high above thunderstorms, are realizing that our atmosphere is far more electrically active and complex than we once thought. Is it possible that under a perfect storm of conditions, these phenomena could scale up to something as powerful as the Tunguska event? Another piece of supporting evidence comes from analyzing the peat bogs in the area. Some studies have found unusual isotopic signatures and chemical compositions in the peat layers corresponding to 1908. While some interpret these as evidence of cometary material, others argue they could have been created by the intense heat and electrical reactions of a massive atmospheric discharge. Interacting with the air and soil, the high concentration of certain elements could be the result of a powerful plasma arc, rather than extraterrestrial dust. So where does this leave us? The Tunguska event remains a puzzle. The leading scientific consensus still leans towards the explosion of a small asteroid or a fragment of a comet, as it's the simplest explanation that covers most of the facts. The lack of a crater is explained by the object disintegrating completely in a massive airburst several kilometers above the ground. But the electrical storm theory offers a compelling alternative that elegantly explains some of the event's most bizarre features: the standing central trees, the strange burn patterns, the magnetic disturbances, and the glowing skies. It forces us to consider that the greatest threats might not always come from the depths of space, but can also be born from the powerful and mysterious forces of our own planet. Whether it was a rock from the cosmos or a bolt from the blue of unprecedented scale, the Tunguska event serves as a humbling reminder of nature's immense power. The forest has since regrown, but the memory of that day in 1908 continues to challenge our understanding of the world. Perhaps the truth is still out there, waiting in the Siberian wilderness, or hidden within the complex physics of our own atmosphere. What do you think happened that day? Let me know in the comments below. Thanks for watching, and if you enjoyed this journey into one of history's greatest mysteries, don't forget to like, subscribe, and hit that notification bell for more deep dives into the unexplained.